Okay, guys, we're talking about matter, and we're going to do a little experiment here. So for people who are doing this from home, what you want to do first is you are going to go to mosamack.com, log in with your Google account, and then you're going to go to the unit's called Matter and its interactions. Once you get in there, the lessons are on the side here. You click the solve, and then we should have already done the mystery by now in the vocabulary and episode questions. So we're on step 4, mass. So once you click on that, it has directions for you, and you're going to fill in afterwards. So you can either just watch this and use it, or you can do it along, or you can, and we can leave an antacid tablet for you if you want to do it on your own. Okay, so we're talking about conservation of weight in matter. So here's the question. So the scientists at NASA have discovered a notebook with instructions to create a new substance. It seems that they're making an interesting claim about mass before and after combining materials. They've asked you to follow the directions and write your observations about what happens. The directions are: read the instructions, write your claim based on the instructions. So what do you think will happen? What do you think is going to happen with this? That's your claim. Then follow the instructions. Next, you write your evidence. What did you see? What happened? The facts. And then the reasoning. The reason for what you think happened. And then you answer the discussion questions. So we're going to start here. So first off, there's 2 things you have to know. The first is matter. Everything is matter. Your matter, I'm matter, desks, cups, your pet dog, we're all made of matter. What that means is that we all have the little building blocks that make up everything, which are called atoms and molecules. Were you going to answer the question?
No, I was, but there is a girl.
I know, it's okay.
Wait, but
I'm filming a video. I know, that's okay. Filming a video. Okay, so.
Can you restart it?
No, I'm not restarting it.
No, please.
No, because this took a long time. I'm not restarting. Please, quiet.
Sorry.
Sorry, guys. No big deal. All right. So matter, everything is matter. It's everything that has mass or takes up space. Now, the other word you have to know is mass, and mass just simply means how much matter is in something. So if you look at me, if I said, what is my mass? That would be how much matter, molecules and atoms and building blocks, are inside of me. We can measure mass by using scales. So I have a little gram scale. We're gonna do some measuring of mass. So the first thing we have to do, now this is the question. Here's a question, okay? If I have an antacid tablet, you can see all of me?
Yeah.
An antacid tablet, and I've measured out 50 milliliters of water. If I were to add the tablet up, plus the cup and the water, plus, what's the other thing? Oh, and this baggie. If I were to combine how much they weigh, and then I did a chemical reaction where I put the antacid tablet in the water, let it do a little chemical reaction, is it going to weigh the same, or will it have the same mass, the same grams, before, when we just added them all together, as after? So we're gonna try it. So first things first, we've already measured out 50 milliliters of water. We're gonna weigh that water, then we're gonna weigh all the rest of the stuff to see how much it is together. So I'm gonna click on here. So the Ziploc bag, we'll do that guy first. So you have to have a big one for this because it's gotta hold 50 milliliters of water. So I have my gram scale. I'm going to put it on there. Try to have it so this is the problem. You have to try and have it so it's not touching anything, because that might mess up the weight. So this says, I'm waiting for it to stop, 3 grams. So the Ziploc bag, here we go, 3.0 grams. We just do G for grams. Okay. Now, see, now it says it's gone down. May or may not be very accurate, so we're gonna kind of see. Because now it says 2.5. We'll say 2.5 since we're kind of giving it a minute to. So I don't understand these scales because it's still going down, which is very weird. Maybe we need to use a different scale. let's try that because it keeps going down. It's going 2.5, 2.4, 2.3. Can't get an accurate reading if it doesn't work right. So let's try.
Seems like it's broken.
Well, these are the school scales, and they're tiny. I didn't want to use the really tiny one because I thought, see how cute and tiny it is? I thought I wouldn't be able to put all the stuff on top of it. So let's try it now. Let's see if this is gonna work. You turn it on. If your little scale isn't at 0 when you start, you have to hit a button called tare to reset it. So it's at 0. The units are already in grams. So I'm gonna do the tablet first. The tablet, it says, weighs 3.24 grams. One tablet is 3.24 grams. Okay. And it stayed the same. Yay! That means it's probably a little bit more accurate. Okay, so let's do the next one. Let's weigh the baggie now. Try to get it so it doesn't touch anything to mess up the weight. Okay. Yeah, that other scale must have been messed up because it's not touching anything. But it's, oh, is it though? Nope. 6 point.
You can't even be touching the back. Don't even have the bag like touch your dress a tiny bit, because then it will mess it up. You kind of just like gotta place the bag on and just leave it and don't let it like touch your dress or anything. So when you put it on,
See, this is the hardest part. Darned bag. Okay, that's a little bit better because I folded it all up. So let's see what it says. Can't see through the bag.
Now it's unfolding, so it's gonna be less. Or more most likely.
See, 11 point. Sorry guys, this isn't very fun, but I want to make sure it's accurate. Otherwise, it's not gonna be right at the end. So. Ah!
Oh my gosh. Bags don't fold.
We'll start with we'll say what we started with.
Oh.
Which was 11.99.
That won't work. I was going to suggest that you staple it, but like.
The staple will weigh.
It will weigh.
I know. Okay, so we've done that. Now we just need to do weigh the 50 milliliters of water in our beaker. So I'll put that one on next. That one is 119.13 grams. Now, I tried to line these up so we could find the total of all of them. So, 9 plus 4, so let's see, 13, 14, 16, 16, 13. Gotta make sure. So the total I have is 100, and it should be up here, total mass, 134, sorry, that's a 1.36 grams. Now, we're gonna see if we do the chemical reaction in the bag, if it stays about the same. If it does, we're gonna make a claim that I think that it doesn't matter if we add everything up separately before. After the chemical reaction, I'm going to say there's still the same amount of matter, so it should weigh the same. So we're gonna try this, we're gonna test out our claim. So in your claim, that's the claim you're gonna make. I'm gonna weigh this one more time just to make sure that we have it pretty much correct. Otherwise, now the other problem is there's nothing we can do about it. There's gonna be air in this. And air does weigh something. You might not think it does, but air has matter in it and therefore weighs something. Yeah, see this one says 11.89. So if we say 89's right, that would be 0.26. So we'll say about this. Okay, now this is what you do next, okay? If you're doing this at home, this is what we do now. We've weighed everything separately. Now we're going to do the chemical reaction. So this is how you do it. You're going to put the beaker of water inside the bag like so. Okay, now, once you have it in there, what they want you to do, and this is going to be very interesting, they want you to put the tablet in the bag, but not inside the beaker. So don't cause the chemical reaction yet. So let's try this, and I'm gonna try to get out all of the air that's in here because we have the bag pretty much smashed flat, but the air is gonna weigh a little bit. So not going to be exact. So
This is the good part. When it explodes, I did it last year.
Okay, so let's see. I'm going to try keeping the bag sealed. Actually, let's see what it is without. That's the same thing, that's everything together. And that one says 130.20. So they're almost about the same. If I put everything in the bag, it weighs about 130.20. So a tiny bit less, but that's to be expected. It's going to be a bit different than when I had it all folded up. So now I'm going to put it in here. And what we do is we put the Alka-Seltzer tablet in, but we have to wait 90 seconds for it to finish. Okay?
Oh my gosh, wait, does it explode or is that me just like...
It just fizzes in the water. If you want to bring the camera up closer to show the fizzing.
Okay.
Because this is the same, you guys know what this stuff is, right? Antacid and pain relief. It's that fizzy stuff that you take if you have like a cold or a fever or a headache, and it kind of
Last year,
has medicine
I
in
think
it.
we might have put a different chemical in water, but something
We had
exploded
colored
in
ones.
science. Now it's not focusing on you, it's focusing
Okay,
on
so
that
I'm looking
thing.
at the time. It's gone about 30 seconds. What's your question? This is a science video that's going out to all 4 classes, so what do you need? No, it's okay. Nobody's seeing you anyway. Okay.
Sorry about my brother.
We are almost to, I don't want to start this, sorry. They don't know you. We've got about 30 seconds left. Sorry. If you want to take up the time, read it for a minute, do a little bit of flossing. Ridiculous, I know. Ridiculous.
It's not focusing on you, so no one
Okay,
can
so it's
literally
been
see
90
you.
seconds. So
Okay.
now, let's see, now that it's in there, pretty good. Is it going to make a difference whether and this is a chemical change, meaning now we have a new substance. Is it going to weigh the same though? Let's see. Let me zero it out first. Okay. We'll put it on here. And let's see if we get about the same weight. It's going down. I'm waiting for it to stop. Let's make sure the bag isn't touching anything. It's still moving, so I'm going to wait for it to stop completely because I want to make sure we get the right weight. Seems to be stopped on about on about 131.21. So now let's go ahead and compare these. Now, again, this is off by a gram, but you know how tiny an amount a gram is, and it's probably because the air weighs something, right? So look, we have almost the exact same amount of mass before and after. So our claim would be, let me discard this. You can fill in my numbers if you can't do this at home. Our claim would be that the mass stays the same even after chemical reaction because it's still the same amount of matter, okay? So we're gonna put that there. Number 4, scientific data used to support the claim. What was our evidence? We used a scale, we weighed it. We started and we weighed everything separate and then we weighed it together, right? And our reasoning connects evidence to the claim. Our reasoning is, how does the evidence support the claim? Well, the evidence clearly shows that they weigh about the same, they have the same mass. So there's the mass, there's the same amount of matter before chemical reaction and after. Okay. If you're on your own, you do not need to do the discussion questions, but you do need to submit the assignment. So we'll say bye for now because I think the video is long enough. So thanks, guys.